Welcome intellectuals to our today's wonderful tutorial, which is also going to mark an end to our topic which we started a long time ago, which is vibration and waves. So here we're going to talk about interference of waves. The question is very important, which you are going to receive on this part, and in fact it's very simple to answer, but you have to get the concept very well for the sake of MCQ question that may arise from this topic. Okay, so when we talk of interference of waves, so so interference of waves occurs when two or more waves pass through each other. Okay, when two or more waves pass through each other, they are not going to ask you how to define it. Okay, so when two or more waves pass through each other, what is going to happen? Okay, this these two waves, they are going to meet by two. Interference of waves can occur in two parts, or I mean in two types. There is destructive interference and constructive interference. Okay, so an overview. Let's say, for example, you have these two waves. Let me talk about maybe a structure of a wave. We also have another wave. Okay, you can see these two waves. So as you can see, my main area interest will be about the amplitude. The amplitude is on top is +1 and below is -1. Same applies to here, +1, -1. But what you need to understand here is that the top part of the wave is called the crest, and the lowest part here is called the trough. So what happens is that when two waves meet, okay, if the crests align with the crest, okay, if the crest align with the crest, let me say crest to crest, if these two align, we are going to have the type of interference which we call constructive interference. Constructive interference. And this constructive interference results into what? Into an increase in amplitude. So what I mean is that if these two waves meet, okay, if these two waves meet, okay, what is going to happen is that you are going to have, if this the amplitude of this wave is 2 meters and the amplitude of this is 1 meter, what you are going to have is a wave which is going to have an amplitude of 3 meters. Okay, the amplitude of 3 meters. So under constructive interference, it occurs when the crests of the two waves align, and it's going to increase, it is going to result in an increase in the amplitude. The amplitude are going to add, and this is true because the crest is positive and the crest is positive. But let's say, for example, the two waves meet in such a way that the crests align with the trough. Okay, so this kind of interference, we call it destructive interference. because these two waves, it is going to result in a decrease. In fact, the most important thing you need to take note is that when two waves meet, okay, the two waves are not going to be destroyed. None of the wave is going to be destroyed or altered. What is just going to happen is that's the change in pattern. Okay, we're going to have the change in pattern of the wave as the result of the change in what? In amplitude. So the destructive interference is going to result into a decrease in amplitude. We are going to have the decrease in amplitude in such a way that the amplitudes, we are going to subtract the two amplitudes. So for example, if we have this wave, okay, you see this wave, and another wave now starts from here. You see that these two waves are in different ways. The crest is here, it is aligning with the trough here. That means to say we are going to have a destructive interference where the amplitude are going to be subtracted, and you are going to have a deduction in the what? In the amplitude. That is the one thing you have to appreciate. So during constructive interference, the waves are in phase. What do we mean when we say the waves are in phase? It's because the crests and the crest are aligned. And when the crest align with the trough, we call that out of phase. The waves are out of phase. So that is the information you need to get. But the question is very, very simple. Let's go into a question. We can even answer it in 1 minute, even in 30 seconds. It came in the previous, I think in the last two intakes, the same question. They like to repeat it, more especially in quiz and the exam and tests. You're going to meet a question. So a question comes like this. So a wave of amplitude, the wave of amplitude 0.3 meters interferes with a second wave of amplitude 0.2 meters. So we have two waves. Wave 1 has the amplitude A1, which is 0.3 meters, and the wave 2, the amplitude 2 of 0.2 meters. These two, they meet and they are traveling in the same direction. What are the largest and the smallest resultant that can occur, and under what condition will this maxima and minima arise? So the maxima is resulting from the largest amplitude. So to find the largest amplitude, you just add the two. So the largest amplitude, you see the largest amplitude is going to be equal to amplitude 1 plus amplitude 2. So the largest amplitude is going to be equal to 0 point. In fact, you have to put this in the amplitude should be positive, so I have to put in absolute values to show that our answer should be a positive value. So 0.3 plus 0.20. So our amplitude is going to be equal to 0.50 meters. Okay, so another question is under what condition? So this is going to happen when the two waves are in phase, or they interfere. That is the reason you have to give the interfere constructively. So when under constructive interference, we are going to have the two waves, the two amplitudes are going to meet up. We are going to add the two amplitudes. Okay, then B, the smallest resultant amplitude is going to result from A1 minus A2, which is going to be equal to 0.3 minus 0.2 are going to have the amplitude, which is going to be equal to 0.10 meters. Okay, that is the amplitude. Under what conditions? When two waves are out of phase. or you say when two waves interfere destructively, when destructive interfere occurs. Very simple. So the same way I've just answered is the same way you can answer this question. I'm telling you, you're going to meet this question. So this is where we hinge on vibration and waves. So the next lesson will be on we'll be talking about we are going to start sound. So sound is also the very longest topic also. So, but the very important thing is that in physics, in semester 2, we only have few topics, like I told you from the beginning. So you can see how long we've taken to just handle vibration and waves. So in the next lesson, we are going to be talking about sounds. And before we start sound, before we go to the other topic, we will try to solve more questions from exam papers. But you can see that the question that I've been using are exam question papers, so you should be taking note of this question that I've been giving you guys. So thank you for watching, guys. See you in the next